So let's move on to what this lecture is all about. So what is a computer network? Components, what are or how are networks used, and why are they used? Some useful network commands just to get you started. Client-server model, different uses of computer networks, and I'll move on to chapter 2 as well later on to talk about network classification. Okay, let's start with the basics. So networking, where are they? What are they? So again, Brooke as well. Brooke, you'll be keeping track of bonus points. So when I say somebody has a bonus point, you just put their name down, and later on we're going to use it. So let's start here. Networking today, where are they? What are they? Okay, so where are they? Help me out, guys. Come on. Where are networking today? Where are networking? Where do you see networking? Just give me some examples. I mean, tons of them, of course.
Everywhere in a city.
Router. What's that?
Everywhere in the city.
Everywhere. Okay, everywhere. I agree. What else? What?
Under the sea, those.
Internet, LAN. Okay, good. Smart cities.
It's even in the satellite.
Satellite. Okay. You have some ideas. Very good. I think it was obvious. Networking, they're everywhere. There's no doubt about this. Okay. They're everywhere completely because computers are very cheap. They're very small. If you go back to Moore's law, you talk about Internet of Things. I mean, are you kidding me? Now my computer desk, the wooden desk, has an IP address. My bathtub has an IP address. My pen has an IP address. My watch has an IP address. Everything is connected because everything is cheap. Everything is super fast. Therefore, networking is everywhere. Even networking, if you think about it, within the same computer, I have multiple cores, dual cores, talking to each other, communicating with each other. So yes, networking is everywhere because technology is very cheap. Internet of Things changed the way we think about networking because we can connect almost everything together. So what are they? Again, multiprocessors, as I told you. If you think about networking, it's not a computer to a computer anymore. It's a processor to a processor. It's devices connected to each other, LANs, WANs, MANs, wide area networks, metropolitan area networks, long haul networks going from one country to another, So networking are everywhere. What are they? Is everything connected? Any device in the world, from a small sensor to a web server connected to another device, is what we refer to as networking. Okay? So the definition of networking is as follows. This is very, very important. Let me go over this. A definition, the official definition, this was defined by Tannenbaum. Tannenbaum was a professor, one of the the gurus of networking. He has a book called Computer Networks that was we refer to it as the Bible of networking, So the definition is an interconnected collection of autonomous computers. I love this. Let me tell you why I love this. For two reasons. There are two major words. There's this, and there is this, autonomous. So these are two words I'm going to focus on in the definition. Interconnected meaning it can exchange information using some kind of communication media. Okay? Could be fiber, could be copper, could be wireless, could be anything. Could be, again, wireless meaning without any communication, or fiber optics, or coaxial cable, or twisted pair, or even any kind of physical communication, or wireless communication, wired or wireless. So if I could exchange information, that's what we refer to as interconnected. Very good. What else? Autonomous, meaning I don't have a master and slave. Something we use a lot in communication technology, the terminology called master slave. What does that mean? It means if master slave infrastructure is like Bluetooth, by the way. Bluetooth is still a network, but by definition, master slave is I have a master. If the master goes down, everybody will go down. He kind of controls all the slaves. This is what we have in communication technology. So autonomous, usually it means we don't have a master slave. Now, another definition is what we call a distributed system. Distributed system, you might see it on Google in different books. Many professors think that a computer network and a distributed system are the same. And that is not correct, not 100% correct. No, they're not the same. Okay, let me tell you the difference. A very, very good question in exams and quizzes in life. Somebody will come to you and say, what is the difference between a computer network and a distributed network or a distributed system? Distributed system, the collection of the computers appear as one single coherent system. So I do not see the collection of computer devices that are connected to each other. So if I have 1 million computers connected to each other, in a distributed system, I would see them all as one. I don't see them as independent computer system. They all appear to me as one simple, coherent system. Okay? We call it a single model. Who could give me an example of a famous distributed system that appears to you as one, but actually it's not one, it's many things connected to each other to give you that specific information? No, a LAN, of course, it's a network. No, a LAN, I could see exactly every single computer device. They're different to me. No. These are devices. What you're typing, not the internet, Sarah, but I'll give you a bonus point. Close enough, Sarah. Close enough. Bonus point for Sarah Brooke. Okay, give her a bonus point. So basically, the World Wide Web, the World Wide Web, the internet, meaning as a www. Go to a web page, everything appears to you as a single web page, as a single page, right? Therefore, this is what we refer to as a distributed system. A computer network, on the other hand, you have exposure to the actual machine. Everything is transparent and visible to you. So I could know exactly all the machines connected in a computer network. In a distributed system, everything appears as a single coherent system. And as I said, everything appears like a document. In the internet, when you go to google.com, what you're seeing, that HTML page that you get, appears to you as one page. That's what we refer to as a distributed system. You don't see all transparency around it. However, in a network, everything is transparent. Everything shows to you as a complete networking system. Okay? So keep that in mind one more time. Distributed system, it's not transparent. Everything is one system to you. Computer network, again, they're very close. They have the same objective. By definition, a computer network, we talk about transparency, exposure, visibility. Distributed system, we talk about invisibility, lack of transparency, and everything shows to you as a simple single computer system. Example of computer network, the whole course. LAN, local area networks, Wi-Fi, Internet of Things. I could keep on going. Everything is computer. You have to remember, think about a distributed system as a subset of a computer network. Okay? Think about a distributed subset of a computer network. Of course, an internet is a network. But by definition, you as a user, for you, it's a distributed system. For them, it's a computer network, okay? Depending on what side you are looking at to it. Okay, very good. So what's the internet? Okay, if you look at some examples of the internet, we'll talk about this later on, but this is a very common topology. Again, a terminology I'm going to use a lot is something called a topology. Topology. Let me write it here. Topology. Something you will see in the labs later on as well. So a topology is how are things connected, okay? So you can see here, I have a local ISP. ISP is Internet Service Provider. So we have like in Dubai, it's Etisalat and Du. We call these ISPs. In other countries, you have different ISPs. So typically, to connect, you have ISPs, as you could see, connected usually to a telephone line, or if not a telephone line, they could have their own dedicated lines connected from their systems or servers to your houses. ISPs within the region could be within the country or within multiple countries. So you have the local ISP and the regional ISP. If you are working within a company, you have a company network. And again, you have switches, routers. We'll talk about them as we go on, the difference between them, connecting everything together. So let's talk about some terminologies. The computing devices, these guys, we call them hosts, okay? Hosts. Then you have networking application running on the hosts. You have communication links. We'll talk about them. This is a communication link. Okay, this is a communication link. That could be wireless, wired, fiber optics, copper, and so on. You have the transmission rate at which I'm sending. We refer to it as bandwidth. Chapter 3, I'll have a whole lecture on this. So it's going to be becoming a little bit technical, but get ready for it. We're going to talk about bandwidth. How do you calculate bandwidth? What does it mean? So when Etisalat says, we give you 100 megabits per second, are you actually getting 100 megabits per second? Are you getting 100 megabits? I doubt it. What they told you is the bandwidth is 100 megabits per second. That's the window. That's the maximum. What you will get is typically data rate, okay? So yes, if you're getting more because you bought, yes, you could get 1 gigabit per second. But again, what the ISP will give you is the bandwidth. What you will get is the data rate. The difference between them is the data depends on traffic, depends on congestion, depends on collisions, depends on how many people are using the system while I'm using it. There are a lot of things that are not controllable. So what they give you is typically the maximum usually allowed, okay? Okay, good for you. If you're getting more, good for you, my friend. What can I tell you? But yes, definition-wise, bandwidth is the window that you are allowed to send and receive. Later on, we're going to talk about throughput and goodput. That's what we send, and that's what we receive. And data rate is the same as throughput. We'll talk about it, okay? So these are terminologies. Get used to them. These are like the ABCs of networking, okay? So make sure you get used to them. Of course, we have routers that forward packets. We'll talk about what's the job of routers, switches, you know, bridges, gateways, okay? Hubs. All these are devices. We're going to have a whole chapter on this. All these are devices that we will use later on. Yes, I'll upload the lecture, don't worry, but after my lecture to allow for, okay? This is recorded, yes. Okay, very cool. So again, this is a snippet of how the internet works. And again, if you want to know more about this, you can always go and Google stuff. But for now, We'll have a whole chapter later on the internet, on different network protocols and so on. So let's define data communication. So we said computer networks, two things. They're autonomous and they're interconnected. They're autonomous and they're interconnected. Okay? That's the definition of a computer network. Data communication, on the other hand, is the foundation of computer networking. What does it stand for? So we have telecommunication. Tele meaning distance. This means over a distance, okay? Tele means over a distance. Communication, I think we all know, meaning sending and receiving stuff. So the definition of telecommunication is communicating over a distance, sending information over a distance, okay? That's what tele means. So by definition, data communication is the exchange of data between different devices over a distance using some kind of transmission media, okay? That's what data communication is, meaning I'm sending data over a distance, okay? Computer networks, it's a bigger definition. It uses data communication to send information, okay? So what's the definition of a network? So we said a set of devices connected to each other, a node. We use the terminology called a node a lot. A node, so if I'm designing a graph like this, okay? For example, this is what we call a node. Again, a node could be a switch, could be a router, okay? We're gonna draw different topologies, as I said later on. So a computer network has different nodes connected to each other, and this line doesn't have to be physical, could be virtual, like dotted, could be a virtual line or a physical line. It means they are connected to each other. Again, and there is a distance. There is a distance between them. And when I talk about distance, I'm talking kilometers, okay? I'm talking kilometers, not meters, of course. We'll talk about this later on. No. Tele is via, tele meaning over a distance. Data is data, doesn't mean medium, no. Data means I'm sending some kind of information. I'm sending bits. That's what it means, okay? Very good. So the 5 major components of a data communication, very important. We have 5 major components of data communication. Number 1, let's look at them. So we have, as you can see, let's number them. Of course, in any data communication, we have a sender. Okay. We have a receiver, of course. Right? We have a medium. What medium they're using. What they're sending, the message. And finally, what protocol they're using. Very, very important. What protocol are they using for communication? These are the 5 major components of a telecommunication. One more time, protocol. It's very important. So what is a protocol? What is a protocol?
Could be the HTTPS.
A protocol is, sorry?
TCP IP?
Yeah, go ahead. Tell me, buddy. Tell me. Protocol?
It's a medium. I mean, I'm CC. Don't know
No.
much
It's not
about
a
it.
medium. Oh, somebody else. Thank you. What's the protocol? Networking protocol or protocol in general? Okay, Clark. Oh, we have Clark Kent. Superman is with us. Clark, well done. Thank you. See, we need Superman sometimes to answer. Okay, as Clark said, bonus point for Clark. Yes, protocol, it's a set of guidelines. Listen to me well. It's a set of guidelines. It's a set of rules agreed upon between the parties for communication. That's what a protocol is. They agree on it. They say, you know what? If I send you ABC, The A means this, the B means this, the C means this. So a protocol, we're gonna see a lot of protocols. Who can give me an example of a protocol? So bonus point for Clark because he's the first one to say it. Who could give me an example of a famous protocol? TCP. Okay, other than TCP.
I said that.
UDP. Okay, well, some people know their stuff here.
HTTP.
Other than UDP, IP. Thank you. What
HTTP.
else? HTTP, Hypertext Transfer Protocol. FTP, File Transfer Protocol. We could keep on going. NNTP, Network News Transfer Protocol. SMTP, Simple Message Transfer Protocol. DNS even is a protocol. You know, we could keep on going. It doesn't have to have P in it. You know, just we said a lot that has P in it, but we have tons and tons of protocol. And the protocols vary from 802.11. 802.11. Who knows what 802.11 is? What is 802.11? Wi-Fi. Yes, Bassem. Bonus point for Bassem. Wi-Fi, the thing you use on a daily basis. That's IEEE 802.11. That's a protocol. IEEE 802.3. That's a protocol. Again, protocols are out there. Most likely, they are developed by IEEE, which is the Institute of Electrical and Electronics Engineer. IEEE developed most of the protocols that we use in networking. Of course, we have the internet forums as well, but IEEE 82.1, 82.2, 82.3, 82.4, we will talk about them as we go on. So long story short, data communication requires 5 major components. Somebody's sending something, somebody's receiving something, there is a message being sent, there is a medium being used, and there is a famous protocol being utilized. We can develop our own protocol. By the way, speaking of protocols, I have my own protocol. It's called what for protocol in networking. Okay? And this is what I did my PhD on. So protocols are developed by people over time. Some are used, some are never used, some are dead, you know? But the idea is protocols are designed and some become commercial protocols like the ones we use now, 82.3, 82.4. Some only remain in the research, okay? Too much noise around me because of, I'm very excited, okay? So let's take a break now. Let's take a break, 15 minutes break, because I think my fuel, I'm running out of fuel. Been talking for 1.5 hours nonstop. So, this was too much, you didn't understand? Come on, we did only 2 slides. Are you kidding me? Ah, Abdurrahman, are you the same Abdurrahman? The guy from CSIT? Yeah, that's you? Buddy, how are you, buddy? Good, good, good. So let's take a break now. If you did not understand, inshallah, you will understand. I think you can watch the video recordings. You will understand. Okay, let's take a break now. Let's take a break. I will see you in 15 minutes. So at 12:15, Dubai time. 12:15. In the meantime, try to mingle with your teammates if you could find them. And I see you in 15 minutes. Yalla. Bye. 15 minutes. Okay. Okay, let's continue. So we're talking about the 5 major components of any telecommunication system. The 5 major components. Again, one more time: sender, receiver, medium, message, and the protocol that they're using. Again, when we're doing this, a lot of questions come into mind. Number 1 is, what are the performance metrics? I mean, what are the things we care about? We'll have more about this later on. But for now, I already mentioned bandwidth. You know, bandwidth, throughput, goodput, and so on. And another one is latency, for sure. Latency is what we call as delay. You know, it's the same thing. But to be more specific, it's actually the minimum delay. Discuss. For now, what I want to think about, and maybe in the tutorial we'll talk about it more, I want you to think about, when do I care about speed? When do I care about, basically, I want good quality versus zero delay. Like some applications, I don't care about the delay. Some applications, I care about quality. I want to make sure if I send 1 gigabyte of data, for example, you receive perfectly, for example, perfectly 1 gigabyte without any errors, without anything. And I don't care about delay, don't care about delay, for example, or latency. And you have some applications, no, latency is so important because if there is delay, the whole application is useless. Who could give me an example? Come on, bonus point. Who could give me an example of an application where I care about delay, meaning delay is my priority,
Online
where
games.
versus quality is okay. Even if I get a batata quality, resolution wasn't too good, still it's fine as long as delay is perfectly zero. Live
So
streaming,
on-
right? Like those who play games.
So, battle royale games. It's very important, the latency.
Okay, live streaming. It doesn't have to be battle royale, but any live streaming games where it's real time. So everything real time, right? If you have real time, you are willing to sacrifice quality for delay, right? So again, bank transaction. What about bank transaction? Bank transaction. I'm doing something on my mobile app for the bank. Do you care about quality or do you care about delay?
Both.
Quality, of course. I don't care about delay. Who said? It's okay. It could be loading for maybe 10 seconds. It's fine. As long as
10
it
seconds
doesn't
is
debit
fine.
my account for $1 million when I only asked for 1,000. You know?
10 seconds is fine.
I mean,
but not like
you could think about this, but it's all about real-time communication versus non-real time. Of course, if I could have both, that's the optimal. But again, sometimes we need to sacrifice latency for bandwidth or for data rate or for how many bits I'm sending or the other way around, okay? So we'll look into it more later on, but this is something we need to talk about. Again, when you talk about multimedia, when we talk about multimedia, we also have something called jitter. That's another QoS. Again, QoS is a terminology we use a lot, QoS. QoS, what does QoS stand for? QoS stands for, anybody?
so. Wait, so people are Googling.
I'm waiting for them to Google, huh? QoS,
Quality of service.
quality of?
Service.
Quality of service. Okay?
No.
Quality of service. So QoS is a terminology we use in many networking applications. You know, what is the QoS factors, criteria, you know, values, and so on. Like we said, latency is one of the goodput, throughput are some of them. And when we talk about multimedia, we have something called jitter. You guys know what jitter is? You've seen it before? Jitter? You see how we have jitter? It's an English word, you know? Jitter is in multimedia when I have like a fluctuation in the quality of my multimedia. It could be a video. If I have some jitter, it's more like noise. Think about jitter as noise in my multimedia. Usually jitter is something we use in multimedia quality of service metric. Okay? So that's another one. I'm trying to give you some ideas here and examples of things you would see later on in the course. But I wanted you to kind of start thinking about them. You know, start thinking about, what does this mean? How do I design this to make this? Is this a priority? Is this not a priority? You know, these are what managers do and designers do. So jitter is another metric. Again, it basically evaluates the noise in my multimedia, the standard deviation fluctuation, some fancy words here and there. But at the end of the day, it's basically, think about it as how much distortion do I have in my multimedia. Okay? Very good. So I've talked about all these kind of metrics, if you think about it, the bandwidth, the jitter, latency, and maybe hopefully the tutorial kind of think about them more. What does it mean for the internet to grow in size? What does it mean if different applications of having one metric over the other, you know? Okay? So good. Let's move on with some cool internet applications, just to give you an idea, like an IP picture frame. I like this, you know, IP picture frame. It's basically a picture frame that has an IP address. Again, we have many other cool, but I'm just putting stuff over the last 10 years. So this is cool application over the last decade, not 2020, you know, last decade, last 10 years. The IP picture frame is cool. Let me tell you what this is. The idea is I had one of these. It's not a normal picture frame. It's an IP picture frame. So my picture frame has an IP address, so connected to the internet, and I put it in the house of my grandmother that doesn't know how to use WhatsApp and Viber and email. And if I'm in the Maldives and I take a selfie, as soon as I take the picture frame in her living room will change. So that was so cool, you know, the last 5-6 years. It's interesting, you know, we never thought about, I don't have to email, I don't have to share. As soon as I take a picture, she gets it on her picture frame. She doesn't have Facebook or Instagram and so on. So it's an actual picture frame in the living room, like a normal picture frame with the physical ones. You know, I think I could take a picture of it. And maybe I'll show you next time. So we have a lot of picture here. And then one of them is a digital one, which is connected to the internet. It is not very old, Sarah. Do you have one? I like when people start claiming technology is old. Who told you it's old? Who told you it's old technology? Okay, now moment of silence. Okay, let me move on. Okay. So this is an IP frame, very cool. I like the weather toaster. Again, I said this is the last 10 years. I'm not saying this came out yesterday. I said the last 10 years. In case you did not see the title, it says the last decade. Okay. Weather, for example, toaster, networking application is cool. Again, I only want to put some cool stuff there. So you can see the weather. How lazy are we, huh? You can see the weather on your toast when you kind of eat it in the morning without checking your phone and checking other stuff, okay? It's cool, it's funny. It says, today's sunny, today's cloudy on the toast itself. Okay. Again, IP phones, of course, this is the last 10 years breakthrough. IP phones, the last 10 years was a really breakthrough. I'm not using normal telephone. I have it in our offices for the last 5-6 years, but it's very interesting. It really changed voice over IP, changed how we communicate. Very interesting. So if you want to compare telephone lines with internet, let's do a quick comparison. Telephone lines with the internet. Telephone line with the internet. So what do you think? Telephone lines and the internet are very similar. Telephone lines connect telephones together. Internet connect computers together. And if you have to remember, internet started by using telephone lines as the foundation of the technology. So the important thing, let me do a quick comparison here. This is interesting. Things on our mind. So if I want to put telephone lines here, and I put the internet here. Okay? Just a quick comparison. In the tutorial, you do more. But if you think about it, the internet, this is something, telephone line, something we call circuit switching. This is what something we call packet switching. Okay? What does that mean? This means for the telephone line, I open my telephone, I hear the beep, toot. It means the circuit is not being used by anybody. I dial a number, the other guy opens his phone, meaning now we are connected. The circuit is established. We start talking on the same circuit that I established when I dialed. When I'm done, I hang up, I disconnect. That's what we call circuit switching. Of course, the internet cannot work like this. Imagine if I want to email you, I need to establish a circuit between me and you, and then I email you, and then I disconnect. Doesn't make sense. So we don't use that. Of course, we use something called packet switching, which basically I send a message, it goes on different paths, different directions, in different pieces. If the packet's big, it's being cut and fragmented into smaller pieces until it comes to the destination. So that's what we call packet switching. What else? What else? This is packet. Think about what's the major difference between these two things. And in the tutorial, you can brainstorm more about the major difference between them, okay? It's interesting how a telephone line works versus a normal internet. Sorry?
Maybe in the landline, we can only hear the audio, while in the internet, it's like infinite possibilities of visual effects.
Of course. The landline was designed for voice, so it uses a specific frequency. The internet, I'm sending data as well. Yes, good. Thank you for sharing. So again, you can discuss it more in the tutorial, but I wanted to give you a heads up on this to think about these two. Obviously, one is based on the other, but how it evolved over time and how different networking evolved over time. Okay? Very cool. Let's move on. So we have IP phones. Here, again, this was the smallest web server about 10 years ago or 8 years ago, developed by UMass in the US. Okay? Again, web server that is this small. No, the lab and the tutorial, Hassan, are the same, okay? It starts as a tutorial, changes to a lab. So this is the world's smallest web server about 10 years ago. We still have smaller now. Of course, now we have at the size of a nano or a micro, at the micro. But this is a coin size, imagine, server. So I could basically Google this. I could access this from anywhere in the world. Obviously, now it became smaller and smaller. So very interesting. It's a server this size, like a Google this size, imagine, okay? So wish I could make a request to it, get a reply. So very interesting. And these are small, cool technologies to kind of interest you in networking, okay, as we move on. Hopefully in the lab, we'll try to do as much as we can with different devices. What powers it? Again, it has a battery. And again, we had others that are based on solar energy and so on. Okay. So what are the components of a computer network? We have hardware, we have software. Again, there is a debate, which one's more important? The computer scientists, we say software is more important. The computer engineers say hardware is more important. So again, hardware, we're talking about all the physical devices. Again, the routers, the switches, the cables, and everything. And the software, we're talking about the operating system, the NOS, network operating system, the protocol that are making everything happen, and to make sure we have access to the hardware. Of course, the software, the job of a software is to allow us to access the hardware. Of course, if I know machine language, if I know assembly, I don't need software, of course. But of course, we don't. We don't know how to on a long scale. Therefore, we need to use software. And when I say software, I'm talking about the operating system that's controlling the whole network. I'm talking about higher level applications, you know, packet tracers. We're talking about networking management software like SMTP, SNMP, Simple Network Management Protocol. So these are higher level, but you could also have lower level, okay? Software, again, is debatable which one is more important, depending on what discipline are you going, okay? I'm gonna go in slow motion now. So let's look at some example of commands that are interesting. Again, we'll look into them more later on, but a famous networking command that you would see a lot in the future, actually two of them. One is called ping and one is called traceroute. These are the two famous commands. Let's start with the ping command. The ping command is a command, we'll be doing it in the lab, by the way. later on in maybe week 6 or week 5. But you do it in the lab, don't worry. But the ping command is very basic command that allows us to see if a device, yes, you could ping that, of course. It's a device, see if a device is alive or not. When I say alive in networking terminology, meaning it's connected to the internet. So I could basically ping any IP address, I could ping any computer name. Very simple command, the easiest command you would see, you know, to check if there is a device that is connected to the internet. And not only that, it will tell you the delay, the latency that it took for the message or the packet that you sent from your side to get to the other end. We have two kinds delay. We have one-way delay and we have an RTT. RTT meaning a round trip time, meaning the time it took for the message to leave my computer and go to the other end. I could try to do it on my computer, see if I don't have a firewall. Okay, just type CMD and you could say ping google.com. Okay, now it's pinging google.com. Again, you could ping an IP address. It's going to time out. I have a firewall, but depending where you're working from what side, it's timing us, not allowing me to ping. It's being blocked. But typically you can ping. You can try from your side. The lab will have these open, so you'll be able to ping. So in this case, I already pinged. You could use Sustworks, which is a portal to ping. It allows you to ping from their side. Try it out. I have a snapshot here. So you can ping any IP address. You could know your IP address again from IP config. So if you come here, we'll talk about these later on. But for now, okay, just type IP config on your portal, on your command prompt. You could basically IP address, as you could see. Okay. Again, you have other information. We'll talk about them later on. Of course, you could also know if you are within a company firewall. Typically, are with. If you go to my IP address, go to myIPaddress.com. It will give you your IP address from the outside. So you can also know the IP address from the outside. What you saw now is the IP address within the company or within the organization you are in. We'll talk about the difference between them later on. But for now, just to get you started, every computer connected to the internet has an IP address, must have an IP address. Otherwise, you cannot connect to the internet. So your phone will have an IP address. And, excuse me, this is blocking. Okay, your phone has an IP address, sensors will have an IP address and so on. You could try it out to figure out how far you could ping any device, and it will tell you the delay it took, the minimum, the maximum, the average, how many packets you sent. 10 were sent here. You could play with that by putting some different attributes to the command, okay? So the ping command is as simple as I say ping the computer name, or ping, if you know the computer name, if you know, ping the IP address. And it will tell you how far is that computer and if that computer is connected to the internet. Okay? So in other words, WhatsApp, when it tells you if someone's online, you know, WhatsApp, basically it's pinging them. That's what it is doing. Okay? It's pinging them behind the scenes. That's what it's doing. Okay. So again, let's talk about very quick to summarize. Why are networks used by people? Of course, networking is very important. You can share resources, of course. Again, like printers, terminals, some architecture. You can share information like the internet, video conferencing, and so on. It improves reliability. Who could tell me how does networking improve reliability? Bonus point. How does networking improve reliability?
There are many reasons, such as people can communicate with each other no matter the distance.
And I'm saying, did you hear my question, my friend? Improve reliability. You know what reliability means? Reliability. Yeah, how does that improve reliability? Reliability, not remotely, no, that's communication.
Because now, especially nowadays, because networks are used by everyone and you can access it from anywhere, and they never really like a network won't, they rarely ever stop working. They're always there and they're working constantly.
Because why? Very clever. Thank you. Bonus point for you. Because why? Can you tell me why they rarely ever stop?
Because there's a lot of why they never stop like working.
You said because they hardly break down, right?
Yeah,
Because
because they're protected by a lot of other secure systems, and they're constantly monitored. So if there even is there an issue, they normally fix it quite quickly.
Okay, not bad, not bad. I mean, you didn't nail it 100%, but definitely bonus point for you, buddy. Thank you. Well done. So basically, what I was looking for is redundancy. Okay, so networks improve reliability because of redundancy. Long story short, if you have a backup, I could automatically back it up in multiple locations. So in case something happens, I still have another path. So if A is connected to B, connected to C, I could also have A connected to E, connected to C. So if this goes down, I have a redundant path that will allow me to connect to it, therefore improves reliability. Reliability by definition means uptime, meaning how many times I fail, fault tolerance. Reliability meaning how reliable is my network, how reliable is my system. So of course, with networking, reliability is very important. And in the tutorial, you see, I mean, you think about it. If I have a network like A goes to B, goes to C, goes to D, and they're all connected to each other, we're saying, no, let's have one big system. We call it a time-sharing system. A time-sharing system. Do it like this. Everybody's connected to this, like this. You can see this is bad, super bad, right? Because this is not scalable. So if I want to add more computers, it's so difficult. At one point in time, it will crash. In a network, I could scale it as big as I want it to be. And a very good example is the internet. The internet started as a small project in California, for the Department of Defense. We called it ARPANET. And then it became DARPANET. And then the universities start jumping in, Berkeley and so on. So it started so small and grew to become the biggest network you could see in your life. Because the design of it was a scalable design. Networking allows us to scale up. If you don't like networking, say, no, I want one computer and I connect everybody to it. That's what we call a time-sharing system. That's what used to happen before. Of course, that's not scalable and not reliable, and something you can discuss in the tutorial with okay, so let's move on. So yes, improve reliability. Okay, improve power per cost. That's also very interesting. So now we can have, before we used to have something called a supercomputer, and used to cost maybe $500,000, Now almost anybody can have access to a supercomputer by doing what? Who could tell me? A super powerful computer.
So can you repeat
How can
the
we do
question?
that? Yes, I'm saying back in the days, 10, 20 years ago, we had maybe 5 or 6 universities in the world that had a supercomputer, which was very expensive. I'm saying today, any one of us can more or less make one. How can we do that?
By going to the PC store.
Picking up your phone.
Like, that's a good one. Going to the PC store, going shopping. No.
Yeah,
How
really.
can we make a supercomputer?
You can
No, it's
buy.
not really. Okay.
You can
I'll
buy
tell you how in a
expensive
second.
parts.
You can mute now. Thank you, boss. Yeah, I'll tell you how in a second. So how can we do supercomputer?
Pick up your phone.
No. Stealing it from the Pentagon. I like your answers. Are so funny. Okay. Come on, guys. Use your head for once. How can you make a supercomputer? Yeah. How? Tell me, Muhammad.
Sir, can't you connect a bunch of computers together in like a mini server and then you'll have like a supercomputer?
Exactly, Zed. Somebody smart here. Thank you, Zed. You're very smart, buddy. Thank
Sir, I
you.
used to live in school
Of
to
course. I mean, do you have to be a genius to know this? Do you have to be a rocket scientist to figure this out? If I want to make a supercomputer, all I have to do is call 50 of my friends, actually on Facebook, post an ad, connect all their computers to mine in a network. They will all act as one big, super fast computer. And many hackers do that all the time. Many hackers do that all the time. That's why in our days now, it's no longer having, for hacking, you need a fast computer, you need a super fast computer. Back in the days, 20, 30 years ago, we couldn't do that. People couldn't hack because they didn't have the access to a super fast computer. Now, what they're doing, they're creating these underground networks, the black zones, they call it. I don't know if you belong to any one of them. So these are things we don't have access to. And then they create a network using their PCs. So if I have a quad-core PC, you have a quad-core PC, and 500 others have a quad-core PC, if I connect them all to work as one, I'm creating a grid. And this is how, yes, some people are saying farmers here. Yes, exactly, Clark. Superman always comes and gives us all these clever answers every now and then. Yes, Clark. Yes, Bitcoin farms, exactly this is how they work. Very similar concept. So yeah, supercomputers definitely are possible in our day and age. Very easy to do. I mean, if I have a computer lab, see the computer lab on campus? If I connect all the computers together, we have about, I think, 300 computers. If I connected all of them together in a clever way, of course, and make them all act as one in parallel, so I will have parallel computing. Yes, it could do wonders. Okay. Okay, let's move on. I mean, I cannot wait to start doing the first quiz to see your grades. This is where I start knowing who is trying to be smart and who's actually smart. Okay, good luck. So let's move on. So power. Let's move on. Stop chatting and focus with me, please. Okay, so again, we have some killer applications. So when we're talking about the final project, start thinking about your design. Sit with your team. Don't wait for the last week because you would run out of time and start begging me for more time. Please, I'm telling you, as soon as you have your teams, you can start working on the final project. Say, what company you're going to pick? What do you want to do? Start drawing your topologies. Start acting upon it. Okay? So let's move on. Again, use computer networks in business application, house application, mobile users, social networking. So computer network can be used in different domains. So hopefully, when you start doing your seminars, you would see the added value of the computer network, especially the emerging concepts of the 2020-21. Okay? So a typical computer network topology, we call it a request reply client server. You could see we have here two clients. We have a network and we have a server. Typically, we make a request, goes here, and then it goes back with a reply. So this is what we call a request reply. Okay? So we'll talk about the difference, how we go about these, but typically a normal client-server architecture, we call this a client-server architecture, is multiple clients using a network. Again, obviously the network will be difficult. Like we have a switch, we have a hub connected to each other. This is what the network is. Okay? So we'll talk about this. I mean, usually we denote it like a cloud. We call this the subnet. Okay? So we'll talk about the subnet later on, but yes, the idea is having multiple clients connected to a server using some kind of a subnet. And we'll talk about different kinds of subnets later on. So you could have a client-server model. Again, as I said, request, reply. You make a request to a server and you get a reply from a server. Again, if you go to google.com, you type google.com, what's happening? What's happening when you type google.com? So you're the client. You typed google.com on your computer. What happened? Obviously, it goes through a network. This is a request you're making. Goes through a network, again, DNS, to figure out the IP address of this computer. Again, this is a server called google.com. Okay? It figures out, you want to go to Google, goes through a network, multiple networks like this. This is your message, goes like this, and then finally your request comes to the Google machine. They run an algorithm to achieve your request and give you the page. That's the first thing. You have a page called, HTML page called .com. Okay? Once you get the page, you type something and you search. Another request will go. The server will find it, will come up with the reply. So this is how you're actually communicating with the Google server. Typically in California. This is in California. Of course, to make it faster, you will have cache, images of Google. You will have local servers like Netflix in the country you are in to make it faster and more efficient. We'll talk about these in other subjects. I mean, of course, in networking, we focus on the network. So in this subject, my focus is this guy. This is what we focus on. What happens here or here are obviously out of scope of this course. We'll talk about it in other subjects for sure. Okay? Okay, good. So we have, again, where can we use home network applications? Of course, have to connect multiple people together for entertainment. I think now we all have Netflix. We have multiple PCs connected to it. So network applications at home are very common. You can have a printer connected to multiple PCs. You could have a local area network, and so on. So these are, again, example of home office network applications. Again, networking could be useful for e-commerce. Again, B2B, B2C, G2C, all these kind of e-commerce applications. You can order books online. Again, doing business-to-business applications. So networking is very important. It's all over the place. Can be used for different kinds of applications. Again, home, office, business online, e-commerce. Wireless communication is very common for networking. It could be mobile and wireless, like your portable office laptop and so on, your phone. It could be wireless but not mobile. For example, desktop computers and offices without wireless connection. So mobility does not imply wireless connectivity. And wireless connectivity does not imply mobility. So you could have either, you could have both. Okay? Let's move on. So networking has obviously effect on society because it allows, again, governments to connect. You have e-governments, you have smart cities, you have the World Wide Web. Again, obviously email communication, forums, social networking, publishing, all these have a major impact on the society. And everybody says if the next world war would not be using weapons, would not be using guns, would be as simple as disconnecting a country. So imagine the US decided, you know what? I want to remove this specific country from the internet. Imagine what impact would that have on that country. So they say the next war will be a digital war. It would not be a normal guns and bombs war. It would be digital or bio. Bio is like the pandemic, like the corona. But a digital war is as simple as disconnecting a country, is as simple as preventing access to the internet. Okay? So yes, effect on the society is humongous, and computer networking has a major impact on the society. Okay?